Okay, so to simplify, we've got a monomial times a polynomial. What we want to do is distribute. So we're going to multiply each term inside the parentheses by this term on the outside. 3 times 5 is 15. X squared times x squared is x to the 2 plus 2, x to the 4th. 3 times negative 3 is negative 9. X squared times x. Add the exponents, we get x cubed. 3 times 7 is 21. X squared. Now we've got FOIL, first, outer, inner, last. Combine like terms, we get x squared plus 9x plus 20. Number 3, more FOIL, first, outer, inner, last. Combine like terms, we get x squared minus 14x plus 45. More FOIL, first, outer, inner, last. Combine like terms. and I kind of knew that where this was going because I could add up the constants 4 and 5. That's going to give me my middle coefficient. Multiply the constants, that will give me my last number. Number 5, I can't necessarily use that trick because I have coefficients in front of the x. So, first, outer, inner, last. Combine like terms, 6x squared. I have to be careful. Negative 27 and 4, that's negative 23x minus 18. Here I've got a binomial squared. I'm not going to just square the individual terms. That's the common mistake. I have to square the entire thing. So this becomes x plus 4 times x plus 4. And then I'll do FOIL. First, outer, inner, last. Combine like terms. And notice my result is this perfect square trinomial. Number 7, same idea. Only difference is there's a leading coefficient this time. First, outer, inner. Notice for both of the numbers 6 and 7, the outer and the inner of FOIL are identical because it's a perfect square trinomial. 8, I've got what we call conjugates, x plus 7 times x minus 7. When I do FOIL, first, outer, inner, last, you'll notice that the outer and the inner combine. So if I notice that, I can shortcut it, and I'll do the shortcut on this next problem. I can see that these are conjugates. I've got a 3x plus 4 and then a 3x minus 4. So I'm just going to get straight to it. Right? I can square the 3x. That gives me 9x squared. I can square the 4. That gives me 16. And it's a minus in between. So notice the results are differences of squares. That'll be important when we go the other direction and factor. All right, now we've got some factoring problems. I see a bunch of terms, but they all have 5s in them. So I'm going to take that out. That's taking out the GCF. And x cubed minus 3x squared minus 5, there's nothing I can do with that, so I'm done. This next group of problems are going to be factorable trinomials. So I'm looking for factors of 24 that add up to 14. And you might see it right away. I'm just going through systematically. 2 and 12, got it. So it must be x plus 2, x plus 12. For number 12, I'm looking for factors of 30 that add up to negative 11. Both numbers are going to be negative because I'm multiplying to get a positive and adding to a negative. So negative 30, negative 1, no. Negative 15, negative 2, no. Negative 10, negative 3, no. That would give me a negative 13. let's see, 8, 7, how about 6? 6 and 5. Okay, that works. So I'll get x minus 6, x minus 5. For number 13, I'm multiplying to get a negative number, but adding to get a positive, so they're going to be opposite signs. And the bigger number will be positive. 10 and 1, that difference is 9. 5 and 2, that's it. That difference is 3. So it'll be x plus 5, x minus 2. Same idea for 14, but here the larger number will be negative. So maybe it's negative 20 and 1. No. Negative 10 and 2. Yep, that adds up to negative 8. So it's x minus 10, x plus 2. Number 15, this is one of those dreaded, difficult factorable trinomials. So let me think. Factors of 12. I'll list all of those. Factors of 10. I'll list those. The middle number is negative. I'm sorry, is odd. So I can eliminate my double positives. 12 times 10 is 120. That's a good bit larger than 43. So I think I'll start at the bottom and work my way up. So I've got 4x and 3x, and I'll start with 5 and 2. So that gives me a 15 and 8. Now I can't get 43 out of that. Let me reverse it. So maybe I'll try 4x and 2, 3x and 5. But that won't work because I can take a GCF out of 4 and 2. And if I couldn't take a GCF out in the beginning, I won't be able to take a GCF out now. So that's no good. Let me try 4 and 3 again, 4x and 3x. But now 10 and 1. I'm not going to try the 10 with 4, that same GCF reason. So I'll try the 10 with the 3. That gives me a 3x. This would give me a 40x. Okay, that works. And it looks like everything is positive. So 4x plus 1, 3x plus 10. So I had to try 4 things really before I got there. Okay, 16 and 17. These are perfect square minus a perfect square. We call that difference of squares. And if you remember from multiplying, you can use the opposite to factor. So it'll be x plus 5, square root plus square root, square root of x squared plus the square root of 25, times the square root minus the square root. Likewise, perfect square, square root plus square root. Right, the square root of 4 is 2, the square root of 49 is 7, times square root minus square root. So when I see a perfect square minus a perfect square, I know I can use this factoring shortcut. Numbers 18 and 19, if I wasn't paying close attention, I might just factor them the normal way, the usual way. Look for factors of 36 that add up to 12, or treat number 19 like a difficult factorable trinomial. But as I go through, I notice perfect squares on the ends. That makes me think this might be a perfect square trinomial. The square root of x squared is x. The square root of 36 is 6. 6 times x is 6x. Double that, I get 12x. So the middle is good. So this must be x plus 6 squared. Likewise for number 19, I see all these perfect squares. The square root of 9x squared is 3x. The square root of 25 is 5. 3x times 5 is 15x. Double that, I get 30x, so the middle is right. This must be 3x plus 5 squared. And if you didn't see that, you have to spend a little extra time. You go through and you factor it like a difficult trinomial. Number 20, I see 4 terms, so I think grouping automatically. So I'll pair this off, 2 and 2. Always with addition in between. Start. Take a 4x squared out of the first term. So I'm taking out GCFs. Left with x plus 3. I better be left with x plus 3 in this next factoring. I'll take out a 7, and I'm left with x plus 3. So I have identical binomials. I'll factor that out. I'm left with 4x squared plus 7. Okay, now I've got some solving. Looks like a factorable trinomial set equal to 0. I think I will use the factoring method. Got to make sure it's set equal to 0. If this were any other number, I'd have to move it over. I've got x plus 8, x plus 4 equals 0. Using the zero product property, I'd set each factor equal to 0 and solve. So subtracting 8 from both sides, I get negative 8. Subtracting 4 from both sides, I get negative 4. So x can be negative 8 or negative 4. Number 22, I see an x squared, but I don't see any other x's, so I'm thinking I'm going to use the square root method. So I'm trying to isolate the x squared. I'll add 12 to both sides. Divide both sides by 5. I get x squared equals 16. That's lucky. It's a perfect square. It doesn't have to be. I'll take the square root of both sides. So x equals, remember, the plus or minus 4. Number 23. Could I factor that? Oh boy, I don't know. I don't know if there's any factors of 59 that add up to 16. But 16 is even. So I'm thinking maybe I'll use completing the square. Half of 16 is 8, and 8 squared is 64. So I would like this to be a 64. I'm going to have to add 5 to both sides. So I get x squared plus 16x plus 64 equals 5. That's a perfect square trinomial. I made it that way. So I can factor it. And then I will take the square root of both sides. So I get x plus 8 equals plus or minus radical 5. And now I've got to isolate x. I get negative 8 plus or minus radical 5. Kind of a strange looking answer. When things don't factor or we can't use the square root method, we often get these strange answers where it's of the form an integer plus or minus a radical. Okay, 24. I can't use the square root method. I might be able to factor this, but I'm not real enthusiastic about trying to factor this mess. So maybe I'll use the quadratic formula. It's equal to 0. I'm just going to pick off the coefficients. A is 12, B is 23, C is negative 24. Some big numbers, but you're going to have a calculator, so it shouldn't be too much of a problem. Quadratic formula, x equals negative b plus or minus radical b squared minus 4ac all over 2a. I'm going to plug in, so I get x equals negative 23 plus or minus radical 23 squared minus 4 times 12 times negative 24. Sorry, I'm squeezing that in, over 2 times 12. So it's a mess of arithmetic. We get negative 23 plus or minus, it's 529 plus 1152 all over 24. That's negative 23 plus or minus radical 1681 over 24. And I'm going to jump ahead a little bit and do that arithmetic. But I get 3/4 and negative 8/3. Okay, last one. We're going to graph this parabola, axis of symmetry. It's negative 6 over 2 times 1, negative 3, that's my middle number. I'll also plug in negative 4, negative 5, negative 2, negative 1. When I plug in negative 1, do a little bit of arithmetic, I get 2, and by symmetry I know that I'll get the same thing when I plug in negative 5. When I plug in negative 2, I get negative 1. Again, symmetry, I know I'll get negative 1 there. And when I plug in negative 3, I get negative 2. So I'm going to plot my axis of symmetry at negative 3. X equals negative 3. Plot my points. Got negative 1, 2. Negative 2, negative 1. Negative 3, negative 2. Back up. Connect with a parabola.